Hello and welcome to my YouTube channel Scholars and Curious. And physics is obviously for curious ones. And you guys know that tagline. Okay, so this is Monica Srivastav. Welcome you all. This is the another video lecture series, the solved questions of GET Physics, which we were doing, and we're targeting the GET 2021. Less than 1 month is rest now. So we are doing solved questions from 2010 to 2020, and our subject was thermodynamics. And the first part has already been released, and now it is the second part where we are going to solve some more questions of GET previous year papers of thermodynamics and statistical mechanics. So here we go. This is our question number 1. For a system of two bosons, each of which can occupy any of the two energy levels 0 and epsilon, the mean energy of the system at temperature T with beta equals to 1 upon kBT is given by, and there are 4 options. Let's first understand this question. In the first video, I was explaining in English only, but from this video, I'll explain in English and Hindi as well for the Hindi medium students. Okay, so इस क्वेश्चन में दो एनर्जी लेवल्स हैं 0 और एप्सिलॉन, और दो बोसोन्स हैं. जो दो बोसोन्स इन दो एनर्जी लेवल्स को ऑक्यूपाई कर सकते हैं. तो हमें बताना है मीन एनर्जी ऑफ द सिस्टम. So if we want to derive the mean energy of the system, I have told you the formula to derive the mean energy. Like first of all, we derive the partition function. Okay, and then we'll apply the formula of mean energy, and then we can derive the term for the mean energy. So this is the answer. There are two boson particles now, so two bosons can be distributed as you can see the table. There are two energy levels 0 and epsilon. There are two bosons, so they the two bosons may be in the same energy state, so the two bosons may be in this 0 energy states, and those two bosons again may be in this epsilon energy states. But one boson may be in 0 energy state and one in maybe epsilon energy states. So these are the all ways by which we can fill the bosons. तो ये bosons को भरने का तरीका है. इस तरह से दो boson आप दो energy levels में fill कर सकते हैं. Now, what will be the partition function? We are following the formula of partition function, which is z equals to summation I equals to 1 to n exponential minus beta ei. Ei is energy. So, summation means the addition of all the types of ways we are filling the bosons. So, z will be equal to epsilon exponential minus beta, and for the first way, the total energy is 0. You can see 0 to both the bosons are in 0 state, plus exponential over minus 2 beta e. The two bosons are in e energy state or epsilon energy state, so 2 beta e, and again exponential minus 0 beta and minus beta e. One in 0 state and another one in epsilon state, and thus we can solve this. So we are getting the partition function as z equals to 1 plus exponential minus beta e plus exponential minus 2 beta e. And now we will derive the expression for the mean energy. So the formula for the mean energy is, we are doing it by long time. You guys should note down the formula. This is the formula for the mean energy if we know the partition function. Now we know the partition function, so we'll put the value of this z here. First of all, we'll derive ln z, then we'll put it in the formula, and then we will do one time derivative with respect to this beta, and we can get our answer, which is this one. Epsilon exponential minus beta epsilon plus 2 epsilon exponential minus 2 beta epsilon over 1 plus exponential minus beta epsilon plus exponential minus 2 beta epsilon. So this is the answer for the question. Moving ahead, this is the question number 2. Let me read out the question first. Consider a system of 3 fermions which can occupy any of the 4 available energy states with equal probability. The entropy of the system is, and there are 4 options. तो ये क्वेश्चन क्या बोल रहा है कि 3 फर्मियंस हैं, 4 अवेलेबल एनर्जी स्टेट्स हैं, तीनों फर्मियंस 4 एनर्जी स्टेट्स में इक्वल प्रोबेबिलिटी के साथ भरे जा सकते हैं। तो आपको ऐसे सिस्टम की एंट्रोपी बतानी है। तो हमें क्वेश्चन को ध्यान से पढ़ना होता है और फिर हम देखते हैं कि हम इस पे क्या अप्रोच लगाएंगे। अब देखिए, हमें जब एंट्रोपी पूछा है तो ऐसा तो है नहीं कि हम पार्टीशन फंक्शन निकालने लग जाएंगे और फिर फॉर्मूला लगा के एंट्रोपी निकालेंगे, ऐसा तो हम करेंगे नहीं। 3 फर्मियन है, इसका मतलब हम बताएंगे पहले नंबर ऑफ वेज और फिर जो हमारा फॉर्मूला होता है एंट्रोपी का S इक्वल्स टू n के ln ओम, उसमें नंबर ऑफ वेज ओम की वैल्यू रख देंगे। तो yes, we'll do the same and this is the answer. There are number of fermions 3, available energy states 4. So the number of ways or the microstates will be 4c3. 4 energy states and 3 fermions. So 4c3. So entropy will be nkb ln ohm. Ohm is 4. We have derived here. So S will be equal to kb ln 2 raised to the power 2. 2 will come down this side. So S will be equal to 2 kb ln 2. So our answer will be B, this one. Okay. Moving ahead, question number 3. Question number 3 is from Bose-Einstein condensation. So in Bose-Einstein condensation, the particles. So there are 4 options and we have to tell the most appropriate one. So option A is have strong interparticle interaction. B is condense in real space. C is have overlapping wave functions and D is have large and positive chemical potential. So in Bose-Einstein condensation, the particles have overlapping wave functions. So the C will be the most correct. Okay, question number 4. This is also from theory, a direct question. For a black body radiation in a cavity, photons are created and annihilated freely as a result of emission and absorption by the walls of the cavity. This is because, and there are 4 options. तो पहले देख लेते हैं क्वेश्चन क्या कह रहा है। एक ब्लैक बॉडी रेडिएशन हो रहा है किसी कैविटी में जिसमें फोटोन जनरेट हो रहे हैं और एनिहिलेट हो रहे हैं, मतलब बन रहे हैं और नष्ट हो रहे हैं। किसकी वजह से? एमिशन और एब्जॉर्प्शन जो कैविटी के वॉल्स के थ्रू हो रहा है उनकी वजह से। तो इसका कारण क्या है, ये प्रोसेस होने का कारण क्या है, और उसके 4 हमें ऑप्शन दे रखे हैं। क्या ये सही होना चाहिए कि केमिकल पोटेंशियल फोटोन का 0 होता है, या फोटोन पाउली एक्सक्लूजन प्रिंसिपल को फॉलो करते हैं, या फोटोन जो है स्पिन वन पार्टिकल्स हैं, या एंट्रोपी जो होती है फोटोन्स की वो बहुत लार्ज होती है। तो कोई भी फोटोन जो होता है उसके लिए जब ब्लैक बॉडी रेडिएशन जनरेट होगा तो उसका केमिकल पोटेंशियल 0 होना चाहिए। बेसिकली फोटोन हैज द केमिकल पोटेंशियल 0, सो द करेक्ट आंसर विल बी A. So we are getting option A correct for the 4th one. Moving ahead, question number 5. Consider a system of n non-interacting spin half particles, each having the magnetic moment mu is in a magnetic field B equals to Bz cap. If E is the total energy of the system, the number of accessible microstates omega is given by. And here are the 4 options. And we have to conclude which option is the correct one. तो ये क्वेश्चन क्या कर रहा है स्टूडेंट्स की एन नॉन इंटरैक्टिंग स्पिन हाफ पार्टिकल्स हैं किसी मैग्नेटिक फील्ड में विच इज अलाइंड इन द z डायरेक्शन, और हमें द नंबर ऑफ एक्सेसिबल माइक्रोस्टेट्स बताने हैं। तो बहुत ही आसान सा क्वेश्चन है। इस टाइप के क्वेश्चंस करने का बिल्कुल ही सीधा सा तरीका है जो मैं आपको बता देती हूँ। ये आपको गिवन है कि B equals to BZ. So n non-interacting spin half particles are there. So the number of ways will be 2. Why? Because spin may be either minus half or plus half. Only 2 spins are possible. That is why 2 ways are possible for the spin half particles. So omega will be equal to 2. So for the 2 number of ways, we can write it down as let us assume omega 1 is equals to for the minus half particles, and omega equals to 2, so n1 is for the minus half particles. Okay, and if the total particles are capital N, so n minus n1 are the plus half particles. Okay, so we can write it as n factorial over n1 factorial and 2 factorial. So they are saying that there is a magnetic field. So we know that the energy in any magnetic field, the energy of the system of particle, we write as N, mu and B. B is for magnetic field, mu is for magnetic moment. So if we want to write N, so how we will put E over mu B? E will be down to this. So N will be E over mu B. So half N minus E over mu B factorial plus and half N plus E over mu B factorial. So this will be our answer. So the correct option will be option number A. Moving ahead towards question number 6. This question is also an easy one. The average energy U of a one-dimensional quantum oscillator of frequency omega and in contact with a heat bath at temperature T is given by. We have to calculate the average energy of one-dimensional quantum oscillator. तो किसी भी वन डायमेंशनल क्वांटम ऑसिलेटर की फ्रीक्वेंसी अगर गिवन हो और हमें उसका एवरेज एनर्जी निकालना हो तो हम क्या करेंगे सबसे पहले obviously we want a partition function here. So how we will do this question is like this one. So the energy of a one-dimensional quantum oscillator with frequency omega is, it is a oscillator. Here they are saying that it is an oscillator. It is an oscillator. So the energy for an oscillator is used to En equals to n plus half h cut omega, where n equals to 0, 1, 2. Now we can write partition function. We know the formula of partition function, which is z equals to summation over n exponential minus beta En. Just put the value of En, this value here. When I am putting the value of En, I am getting this one. Okay, let me separate out this exponential minus beta h cut omega by 2 and exponential minus n beta h cut omega. Now exponential minus beta h cut omega by 2 is a finite quantity. We will put it aside and we will expand the second term. So we are expanding this term only and we are getting, as you can do some mathematical, and you are getting this term. So just put the both the terms together. So we are getting the partition function for one-dimensional quantum oscillator. Here we are deriving the partition function, but you guys should note it down too, because you should always know the partition function of one-dimensional quantum oscillator, because in exam they can ask any quantity like internal energy or entropy or chemical potential or the value of number of particle or the pressure, average pressure, etc. They can ask anything. So you should always remember this partition function for one-dimensional quantum oscillator, and then it is easy to solve ahead. So internal energy U will be minus del over del beta ln z. Just put the value of z and solve it down, and you will get the answer, which will be U equals to half h cut omega cot hyperbolic beta h cut omega by 2. So the correct answer will be option number A. You guys can see how these questions are coming in the exam of GATE, and you guys can easily do the part of the thermodynamics, because I have done all the thermodynamics in my video lectures. I will provide the link of the playlist of thermodynamics and statistical mechanics. From there you can see how I have explained all these things, okay, in a very easy manner. And then if you guys will sit in the exam of GATE, I'm sure you will do all the questions right from the part of thermo and states. Moving ahead, this is our question number 7. So the question is, the entropy of gas containing n particles enclosed in volume V is given by. So we have given the entropy, where E is the total energy, A is the constant, and Kb is the Boltzmann constant. So the chemical potential mu of the system at a temperature T is given by, and there are 4 options. So friends, इस क्वेश्चन में हमें किसी n पार्टिकल्स और जो V वॉल्यूम एनक्लोज कर रहे हैं उस सिस्टम की एंट्रोपी गिवन है, और हमें केमिकल पोटेंशियल की वैल्यू पूछी है. तो जब एंट्रोपी गिवन हो और केमिकल पोटेंशियल की वैल्यू पूछी हो तो हम डायरेक्ट फॉर्मूला काम में लेंगे. वो फॉर्मूला आप नोट डाउन कर लीजिएगा, and this is the answer. So we have given S, and the formula for the deriving the chemical potential is mu equals to minus T del S over del N over constant energy and volume. So this is the formula. You guys will note it down and just put the value of S, the entropy here, and you can easily get the results, which is minus kBT ln AB e की power 3 by 2 over n raised to the power 5 by 2 minus 5 by 2. So the formula is mu equals to minus T del S over del N at constant V and E. Moving ahead, question number 8 is this one. The total power emitted by a spherical black body of radius r at a temperature T is P1. Let P2 be the total power emitted by another spherical black body of radius r by 2 kept at temperature 2T. The ratio P1 or P2 is. Here we have to derive the ratio of the two powers. जो पावर 1 है वो क्या है, किसी स्फेरिकल ब्लैक बॉडी जो T टेम्परेचर पे है और R रेडियस वाली है उससे इमिटेड पावर है, और पावर P2 R2 रेडियस की 2T टेम्परेचर पर स्थित किसी ब्लैक बॉडी की पावर है, और हमें पावर P1 और P2 का रेशियो बताना है. सो वन लाइनर आंसर इज हियर. You guys can solve it like this. P is used to be proportional to A T raised to the power 4, where A is the area, T is the temperature. So we know the spherical black body they are saying. So for sphere, we use the area 4 pi r square. 4 pi and 4 pi will cancel out, and we are getting P1 over P2 equals to R1 square T1 4 above R2 square T2 4. Just we have to put the values of R2 and T2 in terms of R and T, and we will solve the question. We will get the answer as 0.25. It was an easy question but a tricky one too, because we used to study the formula E equals to sigma T4, and if we will use this formula we can never get the results, because the sigma doesn't depend on the radius. Okay, so usually students follow this formula, but you will have to follow this formula for these types of questions where radius or area or quantities like these are given. Okay, moving ahead, question number 9 is here. The entropy S of a system of n spins which may align either in the upward or in the downward direction is given by S equals to minus KBN P ln P plus 1 minus P ln 1 minus P. Here KB is the Boltzmann constant. The probability of alignment in the upward direction is P. The value of P at which the entropy is maximum is. So, to be any quantity maximum or minimum, to derive the value of any maximum or minimum, what we will do? We will just do the differential with respect to that quantity and we'll put it equal to 0. So, the same thing we will do here. And this is the approach to solve this question. The entropy is given for maxima and minima. What we will do? We will just do ds over dp equals to 0. We will put it equals to 0. So we are doing some mathematical and we are getting p equals to 0.5. इस क्वेश्चन को इस तरह से सॉल्व करेंगे तो टाइम भी कम लगेगा और आपके इस तरह के सारे क्वेश्चंस हो भी जाएंगे. तो अगर आपको मैक्सिमा और मिनिमा किसी क्वेश्चन में बताना है, मिनिमम क्वांटिटी और मैक्सिमम क्वांटिटी एट विच एंट्रोपी इज मैक्सिमम, एट विच एंट्रोपी इज मिनिमम, एनर्जी इज मैक्सिमम, एनर्जी इज मिनिमम, सो आप क्या किया कीजिए, जस्ट वन टाइम डेरिवेटिव कर दिया कीजिए और उसको 0 के बराबर रख दिया कीजिए, आपको आंसर जरूर मिलेगा. तो इसी तरह हम आगे बढ़ते हैं. Here we go for the 10th one. For a system at constant temperature and volume, which one of following statement is correct at equilibrium? कांस्टेंट टेम्परेचर और वॉल्यूम पे इनमें से कौन सा स्टेटमेंट इक्विलिब्रियम पे करेक्ट है? ऑप्शन ए इज द हेल्महोल्ट्ज फ्री एनर्जी अटेन्स ए लोकल मिनिमम, द हेल्महोल्ट्ज फ्री एनर्जी अटेन्स ए लोकल मैक्सिमम, द गिब्स फ्री एनर्जी अटेन्स ए लोकल मिनिमम एंड द गिब्स फ्री एनर्जी अटेन्स ए लोकल मैक्सिमम. I will tell here you guys two approaches. The first one is quite easy and the second one is from theory. So the first approach is how I solve these types of questions. So you guys just have to learn this table. Make sure that you will read out this table as I am reading out. At constant entropy and constant volume, del U has the local maxima or local minima, and del U is at equilibrium. At constant entropy and constant pressure, del H is at equilibrium. At constant temperature and constant volume, del F is at equilibrium, and at constant temperature and constant pressure, del G is at equilibrium. So what we have given in the question, we have given constant temperature and volume. So you guys can see at constant temperature and constant volume, del F is at equilibrium. Na? So what is del F? Del F is Helmholtz free energy. Okay, so when we are saying it is at equilibrium, so we are saying it is attaining a local maxima. Okay, this is the first approach. The second approach is this one. Okay, so the Helmholtz free energy defines as F equals to U minus Ts. So dF will be du minus Tds minus SdT. So you guys, if you guys know the value of du, which is Tds minus Pdv, you will put it down here. So you will get dF equals to minus Pdv minus SdT. And they are saying at constant temperature and constant volume. So if temperature is constant as well as volume is also constant, then this dF will be constant or 0. dF will be always 0. So F is either maxima or minima for a system at constant volume and temperature. Now we'll do some approach of second law of thermodynamics. So the Helmholtz free energy at any process decreases. It is always has the value of less than equal to 0. Okay, so the Helmholtz free energy decreases and hence it has minima at equilibrium. So the option will be A. The Helmholtz free energy attains a local minima. So there are two approaches you can see from here as well as you can see from here too. Next question is question number 11, which is saying n atoms of an ideal gas are enclosed in a container of volume V. The volume of container is changed to 4V while keeping the total energy constant. The change in the entropy of gas in unit of NkBlN2 is. इस क्वेश्चन में हमें क्या पूछा है कि एंट्रोपी ऑफ गैस बतानी है. द चेंज इन एंट्रोपी ऑफ गैस हमें बतानी है. एन एटम है किसी आइडियल गैस में जो V वॉल्यूम के कंटेनर में भरी है. कंटेनर का वॉल्यूम सडनली 4V हो जाता है जबकि टोटल एनर्जी कांस्टेंट रहती है. तो हमें एंट्रोपी, द चेंज इन एंट्रोपी ऑफ गैस बतानी है NkBlN2 की यूनिट्स में. एंड हियर इज द आंसर. व्हाट यू विल डू, यू विल जस्ट do S equals to NkBlN delta V. Delta V means change in the volume. The direct approach which I used to apply while solving these types of questions. So NkBlN delta V is the change in volume which is 4. Okay, so 2 NkBlN2 will get easily. Question number 12 is here. Consider a system having 3 energy levels with energy 0 to epsilon and 3 epsilon with respective degeneracies of 2, 2 and 3. 4 bosons of spin 0 have to be accommodated in these levels such that the total energy of system is 10 epsilon. The number of ways in which it can be done is. Now you guys can understand this question कि 3 energy levels दिए हैं जिनकी energy 0 to epsilon और 3 epsilon है और जिनकी degeneracy 2, 2 और 3 है. 4 बोसोन भरे जाने हैं. हमें भरने के तरीके बताने हैं. कितने तरीके होंगे जब पूरे सिस्टम की एनर्जी 10 एप्सिलॉन होनी चाहिए, 10 ई से ज्यादा नहीं होनी चाहिए. तो देखते हैं इसका आंसर. सो वी हैव गिवन E1 E2 E3 G1 G2 G3. सो द क्वेश्चन इज सेइंग दैट देयर आर 4 bosons. 4 bosons. So for the bosons, the number of ways, the formula of number of ways, you guys should remember this formula. Please note it down in your register. It is W equals to omega equals to pi I Ni plus Gi minus 1 factorial over Ni factorial Gi minus 1 factorial. We know that the meaning of summation is to sum up the things. Okay, we just add down the terms. But the meaning of pi is to multiply the things, means we have to multiply the terms. So we'll do the same. There are 3 energy levels, y equals to 1 to 3. We'll put n1 G1 and n2 G2 and n3 GT respectively, and we'll put their values and we can get the result which is 18. So there are 18 ways to fill and to get 10 epsilon energies for this system. There are 18 ways. Okay, moving ahead. This is question number 13. A two-level system has energy 0 and epsilon or E. The level with 0 energy is non-degenerate, while the level with energy is triply degenerate. The mean energy of classical particle in this system at temperature T is. हमें दो एनर्जी लेवल दे रखे हैं, एक 0 है, एक E पर है. पहला वाला जो एनर्जी लेवल है जिसकी एनर्जी 0 है वो नॉन डिजेनरेट है, और दूसरा वाला जो एनर्जी लेवल है जिसकी एनर्जी E है वो ट्रिपली डिजेनरेट है, यानी GI की वैल्यू 3 है. हमें ऐसे सिस्टम की मीन एनर्जी बतानी है. फॉर्मूला वही है U इक्वल्स टू माइनस डेल ओवर डेल बी बीटा एल एन जेड. तो सबसे पहले हमें क्या निकालना होगा? Z. Z मीन्स पार्टीशन फंक्शन. So here we go. We know the formula, which is this one. So this, what is this one? This value is of Z. This is the value of Z. This is the value of Z. And GI is the degeneracy of EIth level. So we'll put the values of this GI and EI and we can get the results, which is this one. So correct option we are getting is option B. Okay, this was an easy question. These types of many questions we have done till now. So I think, yeah, you guys know the answer. Question number 14. This one is tricky question. Let's read out it first. Consider a triatomic molecule of the shape shown in the figure in 3 dimensions. You can see the shape here. This is the shape in 3 dimensions. The heat capacity of this molecule at high temperature is. We have to calculate the heat capacity of this molecule at high temperature. So the temperature is given. About the temperature there are some data. Temperature much higher than the vibrational and rotational energy scales of the molecules, but lower than its bond dissociation energies. Okay, so there are 4 options. तो इस तरह के क्वेश्चंस को हम कैसे करते हैं? अगर हमें वन डायमेंशनल की बात दे रखी होती और हमें पता है कि हर एक एनर्जी टर्म का हाफ केवीटी रोल होता है फ्रॉम द लॉ ऑफ इक्विपार्टीशन ऑफ एनर्जी. 2 डायमेंशन होता तो F/2n केवीटी यानी 2/2n केवीटी हो जाता. 3 डायमेंशन यूजुअली 3 डायमेंशन होता तो 3/2n केवीटी. बट यहाँ पर वाइब्रेशनल रोटेशनल एनर्जी लेवल्स को भी हमें इंक्लूड करना पड़ेगा. तो इस क्वेश्चन को कैसे सॉल्व करेंगे देखते हैं. So the degree of freedom is F equals to 3n minus C. N is number of atoms in molecules and C is the number of constants. So N भी 3 है, C भी 3 है. Just put down the values and you can get the degree of freedom equals to 6. Average energy U क्या हो जाएगा? F/2n kBT यानी 6/2 kBT यानी 3 kBT for the till the rotational levels. Okay, now the vibrational levels will also include. So this 3 kBT plus 3 kBT for 3D vibrations. It is the system of 3 dimension. So this 3 kBT is due to vibration. So 3 plus 3 6 kBT will be the total internal energy, and hence you can get the heat capacity, which is C equals to d over dt. And when you are doing this, you are getting 6 kB. So the correct answer is option number D, 6 kB. Moving ahead, question number 15, which is quite easy question, which is saying a reversible Carnot engine is operated between temperatures T1 and T2, where T2 is greater than T1. With a photon gas at the working substance, the efficiency of the engine is. So the efficiency of Carnot engine is used to be neta equals to 1 minus T1 over T2 if T2 is greater than T1, and 1 minus T2 over T1 if T1 is greater than T2. So yes, this is the answer. Moving ahead, question number 16. Water freezes at 0 degree centigrade at atmospheric pressure 1.01 into 10 to the power 5 Pascal. The densities of water and ice at this temperature and pressure are 1000 kg per meter cube and 934 kg per meter cube respectively. The latent heat of fusion is 3.34 into 10 to the power 5 joule per kg. The pressure required for increasing the melting temperature of ice by 10 degrees centigrade is. First of all, just write down what the values have you given in the question. तो सबसे पहले अगर आप ये लिख लेंगे कि हमें क्वेश्चन में दिया क्या क्या है, तो हमें पता चल जाएगा कि हमें किस फॉर्मूले से इस क्वेश्चन को अप्रोच करना है. तो देखिए, हमें दिया है प्रेशर 0 डिग्री सेंटीग्रेड पर, वाटर और आइस की डेंसिटीज दे रखी हैं, 0 डिग्री सेंटीग्रेड पर ही। लेटेंट हीट ऑफ फ्यूजन दे रखा है, फ्यूजन मीन्स द कन्वर्टिंग फ्रॉम आइस टू द वाटर, फ्यूजन की लेटेंट हीट दे रखी है। तो हमें पूछा है कि हमें कितना प्रेशर चाहिए किसी भी इस तरह के सिस्टम की टेम्परेचर 10 डिग्री सेंटीग्रेड बढ़ाने के लिए। Okay, so how we will solve? We will use the Clausius-Clapeyron equation, the most famous one in thermodynamics. So we can solve this by using Clapeyron equation, which is, just note down this equation. This is your Clapeyron equation, Clausius-Clapeyron equation, dP over dt equals to L over T V2 minus V1. Just note it down. I am putting here a star. An important equation. There are frequently questions coming on this equation in GAT, JEST, NET, IIT-JAM, etc. So dP or dt equals to L over T V2 minus V1. Now we have given the densities of ice and water, but we will use the volume. That is why we want to derive the values of volume of ice and water. So how we can derive? The specific volume of ice will be V ice equals to 1 over rho ice, and specific volume of water will be V water equals to 1 over rho water. Now we have to change the temperature from 0 degree centigrade to 10 degree centigrade. So the change in temperature dt will be 10 degree centigrade. You guys will just convert it into Kelvin, and this is the latent heat of fusion you are given in the question. So just put all these values and you can get the change in pressure is 0.173 gigapascal. So it was the easy method, but these types of questions you guys have to practice more and more. Moving ahead, question number 17 is here. The energy density and pressure of a proton gas are given by U equals to 84 and P equals to U by 3, where T is the temperature, A is the radiation constant. The entropy per unit volume is given by alpha AT cube. The value of alpha is, we have to derive the value of alpha. तो यहाँ पे हमें एनर्जी डेंसिटी और प्रेशर दे रखा है प्रोटॉन गैस का, जो कि एनर्जी डेंसिटी जो है टेम्परेचर की टर्म में है और जो प्रेशर है वो एनर्जी डेंसिटी की टर्म में है, ठीक है। और यहाँ पे जो आपको एंट्रोपी पर यूनिट वॉल्यूम पूछा है उसमें एक अल्फा टर्म है, अल्फा एटी क्यूब, और हमें उसी अल्फा की वैल्यू बतानी है. सो हाउ वी कैन सॉल्व दीज टाइप्स ऑफ क्वेश्चंस? इट इज quite easy approach and the easiest one. The question is easiest one. So u we have given 84, p we have given u by 3. So we know that du equals to minus pdv plus tds. Right. So what you will do, you can do this one. If you will put this temperature here, this T here, so and you will just differentiate all these terms by the volume at constant temperature, then you will get 1 over T del U over del V at constant T and minus P over T and del S over del V at constant T. Okay. So del S over del V at constant T will be this one. And just put the value of du over dv and p from the question, and you can get del u or del s over del v, which is entropy per unit volume, del s over del v. So the value we will get is 1.3384. So this is the value of alpha, 1.33. Okay. So the value of alpha is 1.33. Yeah, here we go. Moving ahead, question number 18 is here. Consider n non-interacting distinguishable particles in a two-level system at temperature T. The energies of the levels are 0 and epsilon, where epsilon is greater than 0. In the high temperature limit, means kBT is greater than epsilon, what is the population of particles in the level with energy epsilon? And there are 4 options. तो देखिए एक बार इसको हिंदी में भी समझ लेते हैं. एंड नॉन इंटरेक्टिंग डिस्टिंग्विशेबल पार्टिकल्स हैं टू लेवल सिस्टम में टी टेम्परेचर पे, और वो जो टू लेवल सिस्टम है उसमें दोनों लेवल्स की एनर्जी 0 और एप्सिलॉन है, जहां पे एप्सिलॉन 0 से बड़ा है. आपको हाई टेम्परेचर लिमिट में ई एनर्जी लेवल में नंबर ऑफ पार्टिकल्स बताने हैं. पॉपुलेशन ऑफ पार्टिकल्स का मतलब नंबर ऑफ पार्टिकल्स बताने हैं. टोटल नंबर ऑफ पार्टिकल्स तो n है, लेकिन ई एनर्जी स्टेट में कितने हैं वो आपको बताने हैं. तो इट इज नॉट क्वाइट इजी, नॉट अ हार्ड वन, बट एन एवरेज क्वेश्चन. सो हाउ वी कैन सॉल्व दिस? So the formula for getting the number of particle or average number of particle, or we can see the population of particle in any energy level, is this one. So if he is saying in energy level epsilon na, so you will do an exponential minus epsilon upon kBt over the partition function. Yeah. If he will say in energy level 0, then you will put n into exponential minus 0 over kBt. Means the wanted level will become upside and then downside the partition function. And then we can solve this. Okay. We are getting this one as average number of particles. But in the high temperature limit means kBt is greater than epsilon. So when kBt is greater than epsilon, that means epsilon upon kBt is less than 1. That means it is very small quantity. That means exponential raised to the power very small quantity. That means 1. So n over 1 plus 1, that means n over 2. So the correct answer will be A, option number A, n by 2. Moving ahead, question number 19, which is saying, consider two particles and two non-degenerate quantum levels 1 and 2. Level 1 always contains a particle. Hence, what is the probability that level 2 also contains a particle for each of the two cases? And there are two cases. The first one is when the two particles are distinguishable, and the second one is when the two particles are bosons. दो एनर्जी लेवल्स में आपको पार्टिकल भरने हैं जब दोनों पार्टिकल या तो डिस्टिंग्विशेबल हो और या बोसोन्स हो. ठीक है, तो पहले हम करते हैं फर्स्ट केस डिस्टिंग्विशेबल के लिए. देखिए, जब दोनों पार्टिकल डिस्टिंग्विशेबल हो, दैट मीन्स वी कैन कंक्लूड विच वन इज 1 एंड विच वन इज 2. सो इन फर्स्ट एनर्जी लेवल A, 1 and 2 both can be stay. The second way may be in A energy level one particle, B energy level another one. And the reversible also reverse process is also possible. So for at least one particle in a state will have probability 2 by 3. Total number of ways you can see is 3 na. Okay, and level 1 always contains a particle. That means if level 1 is always containing a particle, the another particle will be in level 2. So there are two ways. So P equals to 2 by 3. Second condition is when the two particles are bosons. So bosons, both the bosons may be in the same state or maybe in different states, but they are non-distinguishable. That is why we can't label which one is one particle and which one is second particle. That is why there will be half of probability of both the types. So P will be half. So 2 by 3 and half. So the correct answer will be option number C, 2 by 3 and 1 by 2. Question number 20 is, a microcanonical ensemble consists of 12 atoms with each taking either energy 0 state or energy epsilon state. Both states are non-degenerate. If the total energy of this ensemble is 4 epsilon, its entropy will be. These types of questions are coming frequently and the same method we are following. So you might know the method now. So the total energy is 4 epsilon, total number of ensemble of particles are 12. So number of ways omega will be 12 C4. So S is mkBln ohm, omega is 12 C4. Just put the value of 12 C4. You can get the results. Entropy will be 6.204 kV. So 6.204 will get the answer. 6.204. Okay. Moving ahead. Question number 21. An easy one. An air conditioner maintains the room temperature at 27 degrees centigrade while the outside temperature is 47 degrees centigrade. The heat conducted through the walls of the room from outside to inside due to the temperature difference is 7,000 watt. Heat, the value of heat is given. The minimum work done by the compressor of air conditioner per unit time is, which should be work W watt. Okay, so we have to derive the minimum work, and this is the approach to solve these types of questions. T1 we have given, T2 we have given, we know this is the refrigerator, so we will use the formula of coefficient of temperature, which is used to be T2 over T1 minus T2, and both the values are of kappa, the coefficient of performance, which is equal to Q over W equal to T2 over T1 minus T2. So just put all these values and you can get the value of W, which is work done. So W we will get as 466.67 watt. So the answer will be 466.67. 7 here. Yeah. Moving ahead. Question number 22. Two solid spheres A and B have same emissivity. The radius of A is 4 times the radius of B and temperature of A is twice the temperature of B. The ratio of rate of heat radiated from A to that from B is. दो सॉलिड स्फीयर हैं A और B जिनकी एमिसिविटी सेम है. द पावर ऑफ एमिशन इज कॉल्ड एमिसिविटी. A की रेडियस B की रेडियस से 4 गुनी है और A का टेम्परेचर B का टेम्परेचर से 2 गुना है. हमें A और B की हीट रेडिएशन का रेशियो निकालना है. The same question we have done earlier too. So the same approach will do. P A over PB we have to derive here. Just simply I am saying what we have to derive. PA over PB. So P is used to be area into temperature power 4, AT4. So area is for sphere 4 pi r square. So for A 4 pi RA square TF4 and for B 4 pi RB square TB4. We have given RA equals to 4 RB and TA equals to 2 TB. Just put the values, you will get the answer, which is 16 into 16, 256. So the ratio is 256. This is the 2-mark question of GET. Moving ahead, question number 23. The partition function of an ensemble at a temperature T is given. Z equals to 2 cos hyperbolic epsilon upon kBt raised to the power n, where kb is the Boltzmann constant. The heat capacity of this ensemble at temperature T equals to epsilon over kb is x and kb, and we want to derive the value of x. So यहाँ पे हमको पार्टीशन फंक्शन दिया हुआ है और हमें हीट कैपेसिटी निकालनी है. तो अप्रोच वही है हमारी. क्वेश्चन भी वैसे ही ऐसे क्वेश्चंस आई थिंक आपको याद होगा. पहले हम डेल यू ओवर डेल वी निकालेंगे, पहले हम एनर्जी निकालेंगे U और फिर हम हीट कैपेसिटी निकालने के लिए डेल यू ओवर डेल टी कर देंगे. सो पार्टीशन फंक्शन वी हैव गिवन. वी विल डिराइव फर्स्ट द एवरेज एनर्जी इक्वल्स टू kBt स्क्वायर डेल ओवर डेल टी ln z. जस्ट पुट द वैल्यूज. वी विल गेट U equals to or energy equals to minus n epsilon 10 hyperbolic epsilon upon kBt, and the heat capacity C will be del E over del T. Just put the value and at T equals to epsilon upon K. Wherever we are having the T, we'll convert it into epsilon upon K and we can get the answer, which is nk sec hyperbolic square, which is 0.42 nkb. So the answer is 0.42. The x is 0.42. Yeah. Moving ahead, question number 24. So from here, GET 2019 problems have been started. This is the problem of GET 2019. Consider a one-dimensional gas of n non-interacting particles of mass m with the Hamiltonian for a single particle given by H equals to P square over 2m plus half m omega square x square plus 2x. The high temperature specific heat in units of R equals to n kb is. हाई टेम्परेचर पे स्पेसिफिक हीट बतानी है आपको R की यूनिट्स में. देखिए यहाँ पे 3 टर्म्स हैं. एक टर्म काइनेटिक एनर्जी के लिए और 2 टर्म पोटेंशियल एनर्जी के लिए. The first one is half m omega square x square and the second one is m omega square x. Okay, so how we will solve these types of questions? So this is kinetic energy plus potential energy. The average of kinetic energy will have half kBt. The average of potential energy will have half kBt, and the average of x, y, z, I have told you guys earlier too, these contain the value 0. So this will be 0. So half nkbt plus half nkbt will be nkbt. So Cv will be nkb. So 1 into nkb. So the answer will be 1. So option number A is the correct one. Easy question it was. Moving ahead, question number 25. A large number n of ideal bosons, each of mass m, are trapped in a three-dimensional potential Vr equals to 1 by 2 m omega square r square. The bosonic system is kept at temperature T, which is much lower than the Bose-Einstein condensation temperature Tc. The chemical potential mu satisfies. We have to derive the chemical potential and we have given the potential. R square means this is the 3D system, spherical system, na? So we will consider it as 3D system. So how we can solve these types of questions? So at temperature T is less than Tc, system is in ground state. So the population density, or we can say the number of particles in the ground state is 1 over exponential minus mu beta minus 1. ये कैसे डेराइव करना है ये मैं आपको इसी वीडियो में पहले वाले क्वेश्चंस में बता चुकी हूँ. Large number of ng, that means ng tends to 0. So if ng tends to infinite, ng tends to infinite, exponential minus beta mu tends to 1. So mu tends to 0. So chemical potential is 0. Now potential is given Vr, which is spherical harmonic oscillator. So for the spherical harmonic oscillator, the energy is used to be, the term of energy is used to be n plus t by 2 h cut omega. And for ground state, we'll put n equals to 0. So E will be 3 by 2 h cut omega. So for Bose-Einstein condensation, if Bose-Einstein condensation occurs, then E is always greater than equal to mu. Energy, ground state energy should be equal or greater than chemical potential. Hence, chemical potential should be less than the energy. So mu should be less than equal to 3 by 2 h cut omega. So correct option will be option number A. Good question it was. Question number 26 is here. At temperature T Kelvin, the value of the Fermi function at an energy 0.5 electron volt above the Fermi energy is 0.01. Then T to the nearest integer is. This is also an easy question. How to solve this? I will tell you. This is the formula of Fermi density or the Fermi function. Fe equals to 1 over exponential E minus EF over kBT plus 1. Just note it down. I am putting here a star. Important formula it is. So this Fe will come down and this will be going up, then exponential E minus EF over kBT plus 1 equals to 1 over Fe, and by solving and doing some mathematical you are getting this value. And just when we will solve this, now we will get the value of temperature. We are putting the values of E minus EF, which we have given 0.5. We know the value of KB and 1 minus F. F is 0.01, so 1 minus F is 0.99. Just putting all these values, we are getting the value of temperature, which is 1262 minus 3 Kelvin. Moving ahead, question number 27. In a thermally insulated container, 0.01 kg of ice at 273 Kelvin is mixed with 0.1 kg of water at 300 Kelvin. Neglecting the specific heat of the container, the change in the entropy of system in joule per Kelvin on attaining thermal equilibrium is, and the data are given. Specific heat of water is 4.2 kilojoule per kg Kelvin and latent heat of ice is 335 kilojoule per kg. सो इस क्वेश्चन में हमें क्या दिया है, थर्मली इंसुलेटेड कंटेनर है जिसमें 0.01 kg आइस को 273 केल्विन पर 0.1 kg वाटर के साथ में मिक्स करना है 300 केल्विन पर, और हमें बताना है चेंज इन एंट्रोपी कितना होगा. सो विल डू दिस अप्रोच द सेम क्वेश्चन वी हैव डन इन द वीडियो लेक्चर्स ऑफ थर्मोडायनेमिक्स ऑफ माइंड. So yes, it is the approach, and you guys can see, first of all, ice will convert into water at 0 degree centigrade. So phase is changing, that is why m into L. Okay. Next step will be ice will come from 0 degree centigrade to the room temperature. So no phase changing. Okay. Only temperature is changing. That is why mc delta T. Okay. And the final change will be the maximum temperature into the equilibrium temperature. Hence, you can get the value of T, which is the equilibrium temperature. Okay. Now, the change in entropy will be the change in entropy of ice plus the change in entropy of water. You just put the values and you can get the answer, which is 14.85 joule per Kelvin. Moving ahead, question number, okay, so yes, they are solving and they are getting the results. You can do this one. Delta S ice and delta S water. Here delta S ice they have derived, delta S water we had derived, and then I'm putting just doing plus, and I'm getting 1.03 joule per Kelvin. Moving ahead, question number 28. Consider two systems A and B, each having two distinguishable particles. In both the systems, each particle can exist in states with energy 0, 1, 2 and 3 units with equal probability. The total energy of combined system is 5 units. Assuming that the system A has energy 3 units and B has energy 2 units, the entropy of system is KBln lambda. The value of lambda is the easy question. And this is the approach to solve. Okay, so the first way is both the particles should be in different states. So they are different states. There are 4 energy states. So number of ways are 4. Now both the particles are in, okay, what is the question saying? Consider two systems A and B, each having two distinguishable particles. In both the systems, each particle can exist in states with energy 0, 1, 2 and 3 with equal probability. The total energy of combined system is 5 units. Assuming that the system A has 3 energy units and B has energy 2 units. Okay. So to make the system A as 3 unit, we will fill these particles A and B like this. So there are 4 ways to fill this. And to get the energy 2 units, the energy 2 units means up to this level. Okay, so there will be no particle in this third level of energy state, because it will be greater than 2. So there are 3 ways. So the total number of ways is 4 into 3, 12. So S will be KBln omega, KBln 12. Lambda, the value of lambda is 12. Easy. Moving ahead. From here, get 2020 questions are starting. This is the question from GATE 2020. And the rest question are again from GATE 2020. So choose the correct statement related to the Fermi energy and chemical potential of metal, किसी भी metal के लिए. And there are 4 options. So the easiest approach, you guys should always remember that metals में फर्मी एनर्जी को ही केमिकल पोटेंशियल बोलते हैं एब्सोल्यूट जीरो पर. जब एब्सोल्यूट जीरो हो जाता है ना टेम्परेचर, तो फर्मी एनर्जी जो होती है वो केमिकल पोटेंशियल के बराबर हो जाती है किसी भी मेटल के लिए. सो ऑप्शन नंबर ए इज ऑलवेज करेक्ट फॉर दीज टाइप्स ऑफ क्वेश्चंस, द इजी वन. नेक्स्ट क्वेश्चन इज, as shown in figure, an ideal gas is confined to chamber A of an insulated container with vacuum in chamber B. When the plug in the wall separating the chambers A and B is removed, the gas fills both the chambers. Which one of the following statement is true? तो एक क्वेश्चन ऐसे बोल रहा है कि A और B 2 चैम्बर हैं जिसमें आइडियल गैस A चैम्बर में भरी हुई है और एक प्लग इन वॉल है. ओके, अगर हम इस प्लग को हटा देते हैं तो ये जो गैस है ये फैलने लगती है और बी चैम्बर को भी फिल करेगी. अब जो गैस है वो दोनों चैम्बर्स में है, तो इनमें से कौन सा स्टेटमेंट है जो कि सही होना चाहिए? तो ए बी सी डी 4 स्टेटमेंट दे रखे हैं, देखिए पढ़ लेते हैं. द टेम्परेचर ऑफ गैस रिमेन्स अनचेंज्ड. टेम्परेचर कैसे अनचेंज रहेगा? जब गैस यहाँ से यहाँ पे एक्सपांड हो रही है तो टेम्परेचर क्या होगा? डिक्रीज होगा ना. ऑब्वियसली यही थर्मोडायनेमिक्स का लॉ है. तो ए जो है वो कैंसिल हो जाएगा. इंटरनल एनर्जी ऑफ गैस डिक्रीजेस. इंटरनल एनर्जी गैस की तो क्या होगी? डिक्रीज नहीं होगी. टेम्परेचर ऑफ गैस डिक्रीजेस एट इट एक्सपांड टू फिल द चैम्बर बी. ये भी सही हो सकता है क्योंकि टेम्परेचर क्या होगा? डिक्रीज होगा. डी है इंटरनल एनर्जी ऑफ गैस इंक्रीजेस. ये तो हो ही नहीं सकता सही. इंटरनल एनर्जी तो इंक्रीज भी नहीं होगी. सो we are getting option number C as correct one because it is the free expansion case. Question number 31. ये अच्छा क्वेश्चन है और इजी भी है. According to the Fermi gas model of nucleus, The nucleons move in spherical volume of radius r. R equals to R naught a raised to the power 1 by 3, where a is the mass number and R naught is empirical constant with dimensions of length. The Fermi energy of nucleus EF is proportional to. फर्मी एनर्जी और आर नॉट के बीच में हमें रिलेशन बताना है। तो देखिए फर्मी गैस के लिए फर्मी एनर्जी का जो फर्मी रेडियस होता है 3D में, वो फॉर्मूला ये होता है, मैंने आपको पहले भी बताया, यू कैन सी इन माय प्रीवियस वीडियो लेक्चर्स ऑफ स्टैटिस्टिकल मैकेनिक्स, और वी हैव डिस्कस्ड द सेम कॉन्सेप्ट इन डेंसिटी ऑफ स्टेट ऑफ सॉलिड स्टेट. So for 3D the Fermi radius kf is 3 pi square n over v raised to the power 1 by 3. यहाँ पे मैं स्टार लगा दे रही हूँ. This is the important one. Please note it down. This is the important formula. And Fermi energy you guys know EF equals to h cut square kf square over 2m. So यहाँ से देखिए EF जो है वो kf square के प्रोपोर्शनल हो गया, जो कि इसके अकॉर्डिंग 1 upon v की पावर 2 by 3 के प्रोपोर्शनल हो गया. So what is V? V is the volume. The volume of sphere is used to be 4 by 3 pi r cube. So ये 1 over r cube raised to the power 2 by 3 के भी proportional हो गया. So basically this 3 will cancel out this 3 and we are getting EF is proportional to 1 over r square. Now we have given r equals to r naught raised to the r naught a raised to the power 1 by 3. So we are getting directly EF is proportional to 1 upon r naught square. So the correct option is option number C. Moving ahead, question number 32. The internal energy U of a system is given by U equals to lambda V raised to the power minus 2 by 3 S square, where lambda is a constant of appropriate dimensions. V and S denote the volume and entropy respectively. Which one of following gives the correct equation of state of this system? इस तरह का सेम क्वेश्चन IIT JAM में भी आ चुका है, जो कि GAT 2020 में आया है इस बार. तो आपको जैम जेस्ट इनके प्रीवियस ईयर के पेपर्स भी देखने चाहिए, कॉन्सेप्ट भी क्लियर होंगे और क्वेश्चन के तरीके भी पता चलेंगे. तो हमें यहाँ पे बताना है करेक्ट ऑप्शन कौन सा होगा इन चारों में से. तो एक इजी सी अप्रोच मैं आपको बताने जा रही हूँ. वी हैव गिवन u which is lambda v raised to the power minus 2 by 3 s square. We know dq equals to du plus pdv and dq is tds. So from here P is minus del U over del V at constant entropy S. So just put the value of S. Okay, put the value of U energy which is given in the question here, and you can solve this for P. So you will get P 2 lambda by 3 V raised to the power minus 5 by t S square. 5 by 3 S square. Again you can solve it for temperature, which is del U over del S at constant V, and you can get the value of temperature is 2 lambda S V raised to the power minus 2 by 3. Now by options we can check. Option A is saying P over V raised to the power 1 by 3 upon T square should be constant. So just put the values and you will get 1 upon 6 lambda, which is a constant. So yes, option A should be correct. Let's check one more option, which is B. PV over T raised to the power 1 by 3. So put the values of P and V. This is our value of P and this is our value of T now. We have derived. Just put the value of P and T. We are getting not equals to constant. And hence we can check for the option C and D too. So we are getting the correct option is A. Only one option should be correct. So correct option is A. PV raised to the power 1 by 3 over T square equals to constant. Next question is, for a gas of non-interacting particles, the probability that a particle has a speed v in the internal v to v plus dv is given by, this is the formula in the form of velocity fv dv equals to 4 pi v square dv m over 2 pi kbt raised to the power 3 by 2 exponential minus mv square over 2 kbt. If E is the energy of particle, then the maximum in the corresponding energy distribution in units of E over kbt occurs at. Okay, the value of maximum of the energy we have to derive here. So we know this FVdV which is given in the question. In the energy range we will convert this function. We'll convert this function in the range of energy. So we know E equals to half mv square. So dE is mvdV. And just put the values of E and dE instead of V and dV here. Okay. So by putting these values, we are getting FEDE equals to 2 pi over pi kt raised to the power 3 by 2 exponential e raised to the power half exponential minus e upon kbt dt. Now, What we will do for maxima or minima, I have told you, you will just do the derivative with respect to the quantity we have to derive now. So FEDE over DE, this is P, we are getting this one, and for maxima we will just do one time differentiation and then we will put it equal to 0. Just doing some mathematical, we are getting E equals to half kBT, and we have to derive the value of E over kBT. So which will be equal to 1 by 2, which is your 0.5. So the value is 0.5. Okay. So this is the answer. So these are the questions from GATE 2020. So it is all for today. We have done all the questions of thermodynamics and statistical mechanics from GATE 2010 to GATE 2020. Okay, and next video will be on another subject, on maybe quantum mechanics. So yes, all for today. Thank you for watching. Keep sharing, keep studying, keep supporting. Thank you.